Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 9th, 2025, about 4 days ago. The big hook is a single model, Puffin, that treats the camera as language and unifies understanding with camera-controllable generation, delivering strong accuracy with thinking captions, showing median errors of 0.41 degrees roll, 0.74 degrees pitch, and 1.21 degrees field of view. The paper is titled Thinking with Camera, a unified multimodal model for camera-centric understanding and generation. And as we'll see later, the spatial control and image quality are compelling. In short, the model couples a language backbone with diffusion, leverages Puffin 4 million triplets, and uses pixel-wise camera maps to boost fidelity, while instruction tuning unlocks cross-view tasks. Also, the authors shared a GitHub repo. You'll find PyTorch code with configs and scripts for camera-controllable image generation, camera understanding, world exploration, spatial imagination, and photographic guidance. It includes setup instructions, 3 model checkpoints, quick inference commands, dataset utilities for Puffin 4M, plus training and evaluation guides. On Hugging Face, Puffin checkpoints are available, though parameter sizes are not listed. You will find examples for cross-view generation, spatial imagination, image-to-text, and AR object insertion. Those resources were helpful. Figure 1 now showcases what the model actually does. This figure presents a unified workflow that generates views from specified cameras and understands camera geometry from images. The top row highlights camera-controllable generation, where outputs stay consistent with viewpoint cues. The middle row compares horizon lines for understanding, showing accurate roll, pitch, and field of view. On the right, the thinking panels demonstrate text-guided spatial reasoning, and the bottom strip presents world exploration with 3D reconstructions. While Figure 2 shows how the model ties understanding and generation into one pipeline. The left side predicts text and camera parameters from an image because a geometry-aligned vision encoder preserves spatial cues. The right side synthesizes an image from text, discrete camera tokens, and a continuous camera latent, which means a pixel-wise camera map that guides geometry. A connector translates language features into diffusion conditioning, so viewpoint control stays faithful. So Table 1 lays out the training recipe across 4 stages, which explains how alignment, supervised fine-tuning, and instruction tuning are scheduled. The table lists learning rates per stage, a cosine scheduler, and atom W with weight decay. Batch size starts at 1024, then gradually decreases. The longest phase uses 60,000 steps. The data sampling block clarifies that Stage 3 balances text-only reasoning with generation and understanding, while Stage 4 introduces cross-view exploration and photography guidance. Alright, Table 4 evaluates camera-controllable generation on Puffin Gen and shows how closely each method matches the requested viewpoint. Up vector error measures roll against gravity, latitude tracks pitch, and gravity error summarizes vertical alignment. Puffin achieves the lowest median up vector error at about 10 degrees. For latitude, the median error is about 4 degrees, which indicates more faithful pitch control. For gravity alignment, the median error is about 3.4 degrees. Alright, 2 takeaways stand out. Treating the camera as language lets Puffin reason about roll, pitch, and field of view with striking accuracy, and pixel-wise camera maps keep generation faithful to geometry. The broader impact spans controllable view synthesis, spatial imagination, AR, and photography guidance. Thanks for listening. I am Alex, signing off from AI Research Roundup.